afternoon. This is Dr. Jingbo Louise Liu. We are going to discuss your experiment number 5, antacid analysis using titration. Objectives of this lab: to determine the neutralizing effectiveness per gram of a commercial antacid, to strengthen the core knowledge on mastering acids and base, to understand the importance of chemistry in our daily life. First of all, about the acid-base titration. Titration is a standard laboratory method of quantitative chemical analysis. This titration can be used to determine the concentration of an unknown reactant. Because the volume measurements play a very important role in the titration, so therefore the titration is also known the volumetric analysis. So this diagram essentially showed you this is an Erlenmeyer flask, this is a burette, and this is how you are going to read the burette. About some fundamental premises of titration are listed below. The first one, analyte. Second one, titrant. Third one, the endpoint. Fourth one, back titration. Fifth one, buffer solution. Analyte. Analyte is the substance, or also can be called a chemical constituent, undergoing analysis and being measured in an analytical procedure. Second one, titrant. The titrant is a reagent of known concentration. Usually we consider this with a standard solution. The volume of your titrant is used to react with a measured quantity of your reactant. This is your unknown sample. Also is your analyte. Add the titrant into a calibrated burette to determine the exact amount of standard solution. Number 3, the endpoint. The endpoint is a point at which you are going to stop titration. The titration is stopped. Be careful, this endpoint and your equilibrium point slightly different from each other. At the endpoint, theoretically, the number of moles of titrant is equal to the number of moles of your unknown sample, the analyte. Number 4, the back titration. The back titration is an analytical chemical technique, allowing the user to find the concentration of a reactant of unknown concentration by reacting this unknown with an excess volume of another reactant. You know the concentration, or you can have the unknown one reacted with excess volume of unreacted known concentration. The last one, number 5, buffer solution. Buffer solution is a chemical solution which resists the change in hydronium ions or hydroxide ions. When this hydroxide or hydronium added into this system, so with a small amount, not a large quantity, small amount, sometimes including dilution. Buffer solution normally consists of a weak acid and its conjugate base. Buffer solution can also consist of a weak base and its conjugate acid. So when you determine this titration curve, we must have a strong acid or strong base as your standard solution titrant. Your analyte is your unknown. Analyte can be strong, can be weak, can be strong acid, strong base, weak acid, weak base. You are going to measure the pH change of this unknown sample. By a known concentration of your sodium hydroxide, for example, you are going to measure the pH change. Initially, if you have a strong base, titrate strong acid, you call the curve for strong acid, strong base titration. Initially, you have small pH value for strong acid, and then with addition of your sodium hydroxide, you can see the pH slowly increase to about 3, and then what you found within this 39.5 to 39.9 milliliters of solution, this small change, you see a pH dramatic increase. So this indicates your end point or equivalence point is going to be reached. Whenever you have strong acid, strong base that have equal amount, so you have 40 milliliters of the sodium hydroxide, you found your pH reaches at 7. This 7 is your equivalence point. And then you're adding one more drop, 0.1 milliliters of the strong base. You see a color dramatic change. So this color change, you use an indicator. You can use two different indicators. One indicator you call the phenolphthalein. If you use strong base sodium hydroxide to titrate acid, normally we use this phenolphthalein at the 7 pH at 7, so or slightly higher than 7. I think normally from 8 to about 9.7. So the color for this phenolphthalein is also a very weak base, becomes pink. If you use a methyl red, the methyl red becomes a little, I would say, yellowish color, and then afterwards you no longer see the major pH change because you are going to have a basic solution. This is the first titration curve. Second titration curve is a weak acid, strong base titration. You are going to use a strong base sodium hydroxide to titrate in this, such as you are going to titrate acetic acid. For example, you titrate a weak acid, and initially your acid has a pH also smaller than 7. So you will see a region we call the buffer region. This buffer region meaning, so you are going to form a buffer solution, meaning at this point pH change very, very slowly. So you are going to use, say, different indicators, depends on your system. So at a certain point, this point, if you have a weak acid and its conjugate base are equal to each other, this point you call it half neutralization. So this point your pH also equals pKa, and then with the color change you are going to reach the equivalence point. Sometimes we're always using one more drop of your strong base to make the color change for the different indicator. Another case, you use a strong acid as your standard, such as hydrochloric acid as your standard, and then you titrate a weak base, for example ammonia. So you are going to have your pH value from bigger than 7, so slowly decrease in a certain region. This region we call the buffer region. And also you are going to see a certain point you call the half titration. At this point, conjugate base and its weak base and its conjugate acid, they have the equal amount. At this point, your pH also equals to your pKa, not pKb. pKa for the conjugate acid, and then at the equilibrium point, so or equivalence point, you are going to find the color change. So that's the third titration curve. In our case, we are essentially following this titration curve. You are going to use a strong base to do the hydrochloric acid to do the titration on your antacid. So let's take a look about antacid. The antacid is a substance, generally speaking, is a weak base. The antacid counteracts stomach acidity. The antacid is a stomach acid neutralizer. The purpose of all antacids is to neutralize the excess hydrogen ions in our stomach to relieve the acid in digestion. When you discussing acid or base, so normally you can use pH value to represented. If pH is 7, we consider neutral. If pH is smaller than 7, everybody knows it's acidic. Otherwise, pH bigger than 7, you consider it's basic. The pH of the gastric juice in our stomach ranges from 1.0 to 2.0. Actually, it's 2 plus minus 1. So you can say 1 to 2 primarily is a hydrochloric acid. So this hydrochloric acid in our stomach is very important because it is useful for the digestion of the food. If your pH value is smaller than 1, or is meaning you have more acid in your stomach, this you can cause issues, can irritate the stomach linings, particularly the upper level intestinal tracts. Excess use of antacid can help us to increase pH to 2.0. Therefore, you are going to stimulate your stomach to produce more additional acid. So what you are going to see, symptom will be relieved. So in terms of the antacid, so I'm showing you a couple different commercially available antacid, such as magnesium carbonate, magnesium hydroxide, potassium bicarbonate, sodium bicarbonate. Sodium bicarbonate is commonly used baking soda. So this is a very useful antacid. Most of the common antacids composed of the ions, either hydroxide or carbonate. Lately, we also found that citrate is very good antacid. It's a more neutral, more softer. Chemical reactions of active ingredients in the antacid, you must make the active ingredient, active components in the antacid react with the different acid. In our case, we are going to use hydrochloric acid. For example, you have one antacid is called Gaviscon extra strong, so composed of magnesium carbonate and aluminum hydroxide. So you can have different chemical reactions. Sometimes after you uptake antacid, so your gassing may happen because of carbon dioxide generation. So this is essentially about the introduction, about the titration and the antacid. You are going to essentially have two different major procedures. The part A, you are going to dissolve your antacid. I do call it digestion. So you are going to grind your antacid tablets. You measure 0.2000. Make sure you make 3 decimal places, either powder or liquid of the antacid. And then you transfer this into an Erlenmeyer flask, and then you pipe it 25 milliliters hydrochloric into this Erlenmeyer flask, and then you heat it up slowly and meticulously in order to remove the carbon dioxide. Then you are adding 3 to 5 drops or 4 to 8 drops of the indicator, depends on what you are going to use. And then you are going to adding sufficient HCl if it's needed. In this part, I also showed you some ideas you need to be very cautious. There are a couple different indicators, so such as you have this bromophenol blue, so you can have a yellowish color below 3, above 4.6 is 4.6 is a pink color. And when you measure this mass in grams, the decimal place must be 3. Actually, our balance is 4. And then you also need to record the concentration of your HCl, the stock concentration, recorded very carefully. And also 2 decimal places. 0.1 mole per liter of hydrochloric acid, essentially equivalent to the acidity in our stomach. When you heat it up your flask, your Erlenmeyer flask, you wish to remove the carbon dioxide. The second point, the second part of your experiment, so we'll be analyzing the antacid. So again, you are going to use a clean burette to adding that different titrant. So make sure you use mother solution to wash up to clean the burette, and then fill in the sodium hydroxide. So in this case, I want to mention, so this is something special. This hydrochloric is digested. And then you use a large amount of HCl, make sure all the antacid is going to be digested. Therefore, your HCl is in excess. You are going to use sodium hydroxide to back titrate that HCl. From there, based on the color change from yellow to blue for the methyl blue, and then either methyl, I think possibly bromophenol blue, sorry for that, please double check. And then you are going to titrate the sample with the sodium hydroxide. Based on the color change from yellow to blue, you are going to stop titration, meaning your endpoint is reached. And then you read the initial and the final readings, so you calculate the milliliters of sodium hydroxide. The very last step will be dissolving the antacid. The other one will be analyzing the antacid. That's essentially what we are going to do. Also, I want to mention a couple points. Number one, in your burette, in that burette tip, make sure there is no bubbles. And also the readings of your liquid must be 2 decimal places. And then you are, because you have heated up, you need to make sure it's decrease temperature to the room temperature, and you drop wisely titrate this solution using sodium hydroxide. And then you are going to find the color change. When the color change disappears, you're adding half drop. So that's essentially how you are going to analyze the antacid. Now, when you analyze, you're reading this burette. About the burette, you have 2 types of burette. Most of the 50 milliliters of burette, you have a positive negative 0.05 milliliter errors. You have 2 types of meniscus. One is called concave, another one called convex. Concave, when you read it, so your eyesight is in parallel to the tangent of this curved down region. For your convex, so curved up, so you read the value based on the tangent of this up curved value. That's how you measure the different, how you read the different types of burette. So I also gave you one example about calculations. So you are going to dissolve antacid into a hydrochloric acid. Oops. You dissolve your antacid into a hydrochloric acid. Take a certain amount and then let it to be reacting, and then you are going to do the titration. The titration in our case, I should call it back titration. You have sodium hydroxide is going to be back titrated with HCl. This HCl is your standard solution. So your antacid is your unknown. And then from there, you are going to calculate how many grams of this antacid has been used or existing in your antacid that medicine. And then further you calculate the percentage of your calcium carbonate. Up to this point, I believe that's what I want to say. To summarize, you have 2 major steps. First one, antacid tablets digestion. You should see a colorless sample. You need to digest this antacid, and then you use 0.1 mol per liter sodium hydroxide to titrate or back titrate the hydrogen plus. So in each experiment, you do need 3 different duplicate trials. So in that case, to average them to make your chemical reaction more accurate and trustworthy. Thank you so much. You have a beautiful day. Bye-bye.